Well, in this part, we are having a boat which is standing in a harbor where the wind is blowing at this much speed, root 2 meter per second, uh, due to which the flag is fluttering in northeast direction. That means the wind itself is blowing in northeast direction. We shall write a legend like this first. This indicates north and this is east. Definitely it is west and this is south. So wind is blowing in northeast direction. So northeast direction is here in this direction. Okay, so wind is blowing like this. This is the direction of the wind. So whose velocity with respect to ground can be written as VWG is equals root 2 meter per second. In vector form, we always say the coordinate system like this. If this is the x-axis and this is y-axis, so positive values. So then the unit vector what we are having along this side is plus I and along this is plus j. So using this technique, so I can rewrite the expression for the relative velocity of the wind with respect to ground as this, So this root 2 can be split into 1i plus 1j. Otherwise, I can write it as I plus j. So this is how I can write the velocity of the wind in the given coordinate system, and I am calling this equation 1 as I plus j is the relative velocity of wind with respect to ground. So now what we have to think is we have to think about the river which is also flowing. So river is also flowing with a velocity 2 meter per second due north. So river is flowing in this direction. This is the direction of the river, right? So river is flowing in that direction. That means it is flowing in only the y-axis, along y-axis. That means the north direction. So along the y direction means how I can write the expression for the velocity of the river with respect to ground. This is equal to, right? This is equal to only along north direction. That means 2j. This is how I can write. So this is the expression for the velocity of the river with respect to ground. Now the third thing is the boat starts with a zero velocity relative to the river. Okay, so just the boat starts to move into the river with a constant acceleration. You must point out this one relative to the river at the rate of 0.2 meter per square second. This is the acceleration of the boat with respect to river. Okay, so now I have to think about a boat like this, So velocity of the boat with respect to river uh, is equal to, right? So how I can write so which is equal to VO plus AT. This equation may help me now because I know time. So after 10 seconds, what could be the velocity of this boat with respect to river? That I can find it. So that means VBR is equals velocity of the boat with respect to river. So whose initial velocity with respect to river? That means boat's initial velocity with respect to river is 0. It is said here the boat starts with a 0 velocity relative to river. So it is 0 plus how much is the acceleration of the boat, which is at 0.2 meter per square second. I use simply 0.2 and it is multiplied by t after how much time I am finding the velocity, which is 10. So that means in total what I got, which is 20. I mean 2. So the 2 meter per second will be the velocity of the boat, and it is in what direction? So that should be in this direction, due east, due east. So due east. So that means how I can write this VBR. So VBR is equal to, I should represent the east direction. East direction is along x-axis. That means I. So this is a VBR. And now I have to write the relative velocity of the boat with respect to ground. So relative velocity of the boat with respect to ground is equals, so what happens, a buddy who is standing on the bank of the river watches the boat is in some different direction. That means the river is also flowing, and the boat is moving to east, right? So river is moving like this. This is the direction of the river, and here will be the direction of the acceleration of the boat. It tries to move in this direction. As a result, it may move like this. The effect. Okay, so boats affect may like this. So now here it's we can simply think, boat, if a boat moves in this direction, definitely the wind flutters the wing in opposite direction. That means in this direction the flag may flutter. uh, Flag may flutter. So this direction is nothing but southwest direction. Here you can think. That means our answer must be southwest. Definitely it is. Let us check with expressions. So this is how I can move further. So now what I have to think further is, I am writing this one. The river velocity is already said with respect to ground. It is this one. That means I can write V R G plus velocity of the boat with respect to river. This should be written. So in total what I can write, so I can write velocity of the boat with respect to ground is equals, it is 2i, okay, so 2i plus VBR is 2j, so which is 2j. So in total this becomes the velocity of the boat with respect to ground. I call it the third equation. If I want to know, okay, so if I want to know the velocity of the wind, actually the effective velocity, in what direction the flag flutters after 10 seconds. This is the question. This was the question, and for that I find velocity of the wind with respect to ground. Now velocity of the wind with respect to ground, sorry, velocity of the wind with respect to boat or river. So this is what I have to find. I rewrite it, velocity of the wind, right, with respect to boat. This is what I need finally to get the direction of the fluttering flag. So VWG, this is equal to what I have to do is velocity of the wind with respect to ground minus velocity of the boat with respect to ground. These two things should be made subtracted. So if we do this, velocity of the wind with respect to ground, so which is written like this, I plus j. So this is from equation 1. So it is I plus j, and minus this one, which is a VBC. So this one, that means it is 2i plus 2j. So this is equal to minus I minus j. So this will be the direction of okay, the fluttering flag. So minus I minus j will be the direction. Okay, so is the direction of the fluttering flag. So that means the flag flutters in a -1. Minus I means I is here. Minus means this direction. This is the way, and minus j. Upside is a plus j and downside is a minus j. So minus I minus j means in this direction. So this is what we already predicted here. So that means as seen from the boat or on the ground, the flag flutters in a southwest direction. That means this should be the final answer, option B.